Hello guys, in this tutorial I'm going to show you how to start creating a tile map world in JavaScript. And what you're seeing on the screen right now is an example of the game that I've been working on for several months. It's not finished, and in this tutorial we're not even going to cover everything that's seen here, but I'm just showing this to see what the possibilities are in JavaScript. This game features collision detection, sprite animation, some other things. You can destroy the tiles with the mouse and build your own worlds. There's a tile editor is missing on this site right now, but there used to be one. And also this game features collision detection on different slopes. So this is a 45-degree slope. This is a 30-something degree slope. In both directions, there's some gravity applied here, and there's camera movement that brings you to the next screen. There's no climbing yet, so we can't go down this ladder, but that's where I stopped developing and thought it's time to make a tutorial that describes how to build something like this. In this tutorial series, I decided not to use game makers of any kind, and it's not that I don't like them or anything. There's a lot of really good game maker software out there, and they're all fun to use, but for this series I just wanted to go straight into JavaScript code and just go through all of the steps that are required for making something like this. If for any reason it's just a lot of fun to have that kind of control over your code and do all kinds of optimizations, and game makers basically provide you with a lot of this already created, but when you use them you don't really understand the code or the principles of how something actually works. And again, I don't think that it's a bad idea to use game makers. I might actually even create some tutorials about using game makers, but for this series this is strictly JavaScript. This is a strictly JavaScript tutorial, and I'm going to show you something else other than this demo. So I'm going to close this and open my previous demo, which was an earlier version of this tile engine, and it looked like this. I'm going to close that one. So this was my first demo. This is the very first tile engine I ever created, and I wrote it entirely in JavaScript. And as you can see, there's some basic collision detection. It's not very accurate. I think that there's some jumping too. We can jump. There's no collision detection in both going left or right. It's only colliding with the floor. And if you look closer, there's some the wheels turn when the car is moving. So that's pretty much the very basic tile map editor. And I actually did get it to work with the Xbox controller. It was really cool, and that's something that I'm planning on explaining later on. So you can actually create a JavaScript game and play it with a game controller, which creates a completely different experience when you're controlling it with keyboard and mouse. And let's see. And as I mentioned earlier, there is no collision detection with anything other than the floor. For that reason, the car can fall through and collide with these tiles. And the map is really only 16 by 16 blocks. This was my first test. This isn't really a game, but just an example of how something like this can be created. Very basic. And the car falls down if there's nothing underneath. So there's some gravity. But the thing I want you to look at here is if we go to page source for this entire thing, you'll see the main JavaScript code. And I'll go through this briefly just to give you an overall idea of what's going on here. Here we have some variables, timers, some sprite variables, list of sprite graphics. These are the tiles, rock, wall, water, metal, rocks background, and so on and so forth. Width and height of the tiles 32. There's a bunch of different timers and variables. This is the player object. Creating objects is important when you create games. So each object will be specific to something. For example, player is an XY position, has a width and height, it's a wheel angle for the car, and all these different properties that depend on what the player is. If it's a car, there's going to be a wheel angle. If it's something else, you'll decide what those things should be. This is where the game really initializes. I use jQuery, document ready function. It's a callback function. And at this point, we know that the web page has finished loading. So I initialize collision object and the player object. I have to initialize it with the keyword new. We create context. Then we load some sprites. Wheel, car. I think some of these are remnants from older demos. Like girl.png. There's no girl in this demo. So yeah, I think it's from a previous test. Now we create the world object, 16 by 16 tiles. This is an interesting part where the world is actually hard-coded at this point, and it's 16 by 16. 1 is a brick tile, I think. 0 is nothing, it's just empty space. 3 is the water, and so on and so forth. So you get the idea. By changing the index digit here, you'll be able to change the actual content of the map. So going to the next thing. So this is a set interval. This will be done for each frame in the game. So we draw the world, we do some timer functions, which is where I get controls from the mouse and keyboard. We draw the car, we draw each wheel individually. So previously loaded sprites, the same sprite wheel, we draw it 2 times in 2 different places, and we apply the angle. Then we add controls, keyboard controls and mouse controls. This comes from another JavaScript file that I'll show you in a second. This is a timer function. We run it here on each frame. Basically, it just takes controls from the keyboard and changes all kinds of different parameters for the game, for the player, for the car, and so on and so forth. These are X on the keyboard will do something like this. This is a basic collision detection function that goes through each tile, I think, in the world. So 16 by 16. It takes the index. It tries to see if it's air, don't do anything, continue. If it's water, the same thing as air, just you will fall through the water. And if it's any other solid brick or something else, do the collision with it. And here, this is actually the core of rectangular collision in JavaScript. It basically comes down to comparing some of the corners of each box. If it's true, if this statement evaluates true, then there's been a collision. So do something about it. And at the bottom here, we see I don't think it's, you can probably, there's a canvas tag, and basically that's where all of the sprites are rendered. And so I think that's about it for the source code. Other than that, we have some additional JavaScript here. 2D JavaScript. 2D, this is everything that deals with two-dimensional stuff, which is context for the canvas, the sprite object. Again, as I mentioned earlier, if you create an object for each individual element in your game, like sprite or the player, that's a good thing. So you don't have to create an object for every single thing, but for important things, like a sprite is a standalone object, and it's worthy to actually create an individual sprite object for that purpose. And inside it, it has all kinds of functions: draw, load the sprite, draw the sprite, rotate the sprite. We went through this in my previous tutorial, so we already have a demo for that, and I don't have to explain all of these things in detail. Rectangle, another two-dimensional object. Remember, it's 2D.js, so everything that's 2D related, it's going to go into this file. World, open that up. It's pretty small. It just contains the world object, and it has some offset position, and the draw function basically just draws the entire world tile by tile. Again, we get the ID of the tile. This is the small algorithm that's very commonly used in tile map engines. And again, if it's not 0, then draw it. If the index is not 0, which is error, draw the sprite. Go into the sprites, get them by ID, and just draw it at this position. And do that for each tile in the world. That's what the world.js does. So, and then the last one is controls.js. Controls is just basically the keyboard controls file. I use jQuery here, key down event. And we need two sets of data. Key down, that means when you press down the key, something happens. When you release the key, another thing happens. And there's some basic output into the console, just so you can see whether there's a confirmation that the key has been pressed or depressed. I noticed that when dealing with games, it's important to have these two separate sets of events. One for when the key is pressed, another when it's released. It's just the way games are. There's an event can be triggered on the press or depress action, and that's especially important when you deal with joysticks, and we'll cover that later on. And here's the mouse controls function, which basically it just tracks the mouse movement and calculates some positioning in screen space, so we know where the mouse is at all times. So that covers these three helper functions. And this is the main game code. And I wanted to show you this just to demonstrate from the bird's eye view what's involved in making a small demo like this. There's another principle I want to show you, and that is snapping to tile within the grid. And it looks something like this. You simply have to have something like this in your tile map because it's incredibly important for so many different reasons. First, we need to be able to identify within the grid space, not the mouse space, but within the tile space, where that cell is that the mouse is pointing to. In order to do that, we need to convert mouse coordinates in the screen space. First, we need to map it to this local box, which is the screen. And after that, for example, this would be 0 and 0. But once you move it inside the box, it snaps the tile to the correct one. within the mouse position. So in order to do that, let's take a look at the source code. And it's actually pretty simple. We define the cell width and height, which is 32 pixels by 32. And here I'm using jQuery mouse move event. What these two lines do is they calculate this space between upper corner and this one. And it basically looks up whether the mouse is within this box or not. So local to this screen. And after that, after we have that point, for example, this would be 0, 0. This would be about like 200 by 200 within the space in pixels. And what we need to do, we need to take that XY that we just got within that space and divide it by width and take a floor function, mathematical floor of that, whatever that equals to. And that will give you the number of cells within that space. So we need to multiply to find the final position of the snapped cell. We need to multiply that again by width in this case and height in this case for X and Y. So then we simply check if the value we just calculated here, actually this one, if it falls within the space of the screen, that screen where the game is, not the browser screen. And if it does, basically just draw that tile there using these coordinates that we were calculating using the floor function, the division, and multiplication. So again, this is a very common technique. It's not the only way to do this, but it's one of the ways. And so once you implement this small algorithm here, you will see that the mouse position snaps. It creates this snappy tile effect. This is super important for things like tile map builders, because you want to be able to select different tiles on the grid and maybe change the tile or grab it from, tile set. And this can be used for building the tile map itself by just clicking around and selecting the tiles. And you can create the entire world like this if you have a large enough tile map set. So this is, as you can see, it's very important to know how to do this snappy tile algorithm effect for future reference. So this tutorial is already running over 20 minutes, and I was planning on having multiple tutorials just to cover the tile set, tile map building process. And this was the first part where we covered the theory. And in my next tutorial, we're actually going to go ahead and take all of the things that we learned from the previous tutorial, where with the fiddle, and we're going to take this knowledge that we learned here together with the card tutorial that I've shown you earlier, and we're actually going to start building a tile map for our game. And I hope to see you in my next tutorial. And by the way, recently I was able to start making these tutorials full-time, so I'll be producing a tutorial almost every day. At least that's my goal right now. And if you're interested in supporting me, please go to my website, which is tigrisgames.com, and you'll see all of the information and links to Facebook, Twitter, and other things. So if you could add me there, I would appreciate that. That would be great support to me. Thanks a lot, guys, and I'll see you in my next tutorial.